Hello and welcome to Unit 6, Part 4. My name is Mr. Bell. Today we're going to graph some linear inequalities and then we're going to identify the solution sets. When solving and graphing linear inequalities, it's a good idea to remember the slope-intercept form equation of a line. We're going to use this form to plot and graph our inequality with a couple of additional rules. The difference between the linear equation and the linear inequality is that we have an inequality sign, not an equal sign. So one thing to remember is that if it's less than or equal to or greater than or equal to, it will be a solid line that we plot or graph. If it's just less than or just greater than, it will be a dashed or dotted line that we will be graphing. All the other rules so far still apply that we learned before when we graphed linear equations. We always start by plotting the y-intercept first. In this particular example, it is a -3. That's the first point that I plot. From that point, I then do the slope of the line, which in my case, it's up 2 over 1, up 2 over 1, up 2 over 1. Because it's less than or equal to, means I'm going to use a solid line to graph this. Now, we're going to do something else. Since we're dealing with an inequality, we're dealing with a solution set that's more than just one number. Okay, so the solution set here is all the values less than or equal than the line that I just drew. So if I'm looking for all the values less than or equal to the line 2x minus 3, I would need to shade everything below that line. And I think of the line as a ladder. The area that I have shaded falls underneath the ladder. Any point that I pick in this shaded area will satisfy that inequality. Next example could be a little tricky. This one says to solve and graph x is all the values greater than or equal to -3. Recall from when we graphed linear equations that I'm going to go to where x is -3 and put a dot. And x equals equations are vertical lines. They go up and down. Because this one is greater than or equal to, I know that it's going to be a solid line that I graph. And if I'm trying to shade all the points or the values of x that are greater than -3, greater than or equal to -3, in this case I need to shade to the right of the line that I graphed. Every point in the area that I shaded has an x value of at least -3. In this example, we're asked to graph two linear inequalities, which is basically called a system of linear inequalities. So I'm going to start by graphing the top one, and I'm going to use two different colors for this one. The y-intercept of the top one is a 4. The slope of that line is -3/4. That means I'm going to go down 3 and to the right 4. Because it's just greater than and not greater than or equal to, this one will have a dashed line. And I'm going to go ahead and shade the part that I need to for this one. Y is greater than the line, so I'm going to shade everything greater than or above the line that I just graphed. Now, time to go back and do the second equation, inequality. The y-intercept is -1. The slope of this inequality is up 1 over 2, up 1 over 2, up 1 over 2. Because it's also a greater than, not greater than or equal to, it will be a dashed line. Dashed line just means that we do not include the points that land on the line in the solution set. And then also, if we're going to shade everything greater than that line that we just graphed, I'm going to shade everything above this line. The area here that was shaded double, that got double dose of shading, that is the solution set. That's the area that will satisfy both of these linear inequalities. So all you have to do is graph each linear inequality, use the correct solid or dashed line, shade above or below the line as the inequality demands, and then whichever area is double shaded was shaded for both inequalities, that's the solution set. So every point in green in this case would be in the solution set. Last example, we'll start by graphing the top line in blue. inequality with a y-intercept of positive 4, a slope of down 5 and to the right 3. Because it's less than or equal to, it will be a solid line. And because it says y, we're shading the values less than or equal to the line that we drew. So less than that line would be below that line. Think of it as if it was a ladder, and I'm shading the whole area beneath that ladder. So there's one of my linear inequalities. Now let's go back and do the second one in red. The y-intercept of this one is negative 2. The slope is up 1 over 3, up 1 over 3. It is also going to be a solid line. And because this one says all the values greater than the line that I drew, I am going to shade everything above that line. And recall that that area that was double shaded, the blue and the red, that's the solution set to this system of linear inequalities. Any point in this green area will satisfy both of those linear inequalities. All right, thanks for watching. Hope this helped.